Question 32. The terminal arm of an angle theta in standard position intersects the unit circle in quadrant 4 at the point root 5 over 4 comma y. Determine the value of sine. So the first thing I like to do with a picture like this, the graph like this, a point like this, is to draw a picture. So we know right away we're in quadrant 4. When you are drawing your picture, make sure you start at the origin and then you draw your diagonal going into quadrant 4. Your right angle is always off the x-axis, and now we're going to fill in what we know. So what we know right here is the following. We know that the x-coordinate in the intersection is cos theta. So cos theta essentially is root 5 over 4. And it makes sense that this ratio is positive simply because, right, all students take calculus. So cos is positive in quadrant 4. So if I label my adjacent is root 5, and my hypotenuse is 4. So now I want to figure out my opposite. So I will use Pythagoras for that. I'll let that be represented by y. Y squared plus root 5 all squared equals your hypotenuse squared, which is 4. So y squared plus root 5 times root 5 is 5. And this is 16. So y squared equals, we're going to subtract 5 from both sides, right? Minus 5, minus 5. So y squared equals 11. Y equals plus or minus root 11. In this case, because we're below the axis in quadrant 4, it's just the negative root 11 for this question. So negative root 11. So to answer the question, they want to know the sine. So that's easy now that we have a picture. Sine of theta equals your opposite, negative root 11, over your hypotenuse, which is 4. The other thing that makes sense is the sign on this ratio is negative, because in quadrant 4, sine is negative. So that looks good.